first of all, the last two problems from yesterday that we didn't finish. Okay, so those last two problems were 30 and 31. Okay, yesterday, remember, we were talking about spheres. Now, spheres were fairly easy in that you had just two formulas. Okay, right? We just had two formulas. Okay. So when we are doing these, you pay attention to what the question's actually asking you. So if we look at 30 and 31, it doesn't have a full sphere. It has half of a sphere, which is called a what? Anybody know?
Semicircle.
No. A semicircle is half a circle, but half a sphere is called a hemisphere. Y'all heard the word hemisphere before? Like the Eastern Hemisphere and the Western Hemisphere?
Yeah.
When you're looking at the Earth, okay? So they're a hemisphere, it's half a sphere, okay? So on these, we have half a sphere in number 30 sitting on top of a cylinder. So we're gonna have to use our formulas for a sphere and a cylinder because it wants us to find the volume of that. So we're gonna have two parts. You're gonna do the volume of the hemisphere. And then we're gonna do the volume of the cylinder. And then we'll add those two things together, okay? Now, since the hemisphere is half of the sphere, to find the volume of it, we just do half of the volume of the whole sphere. So our formula for the entire volumes for the sphere was 4/3 pi radius cubed. Does that look familiar from yesterday? 4/3 pi r cubed. Okay, so that's for this is for the entire sphere, but we're only doing half of it. Okay, and then we'll plug in the numbers for that. And then for the cylinder, does anybody remember the formula for the volume of a cylinder? Apparently that would be a no. Okay, for a cylinder, the volume is the, like for our cylinders, our prisms, all of those, it's the area of the base times the height. So the base of a cylinder is what shape?
Circle.
Circle.
Circle. So we have the area of a circle times the height. So those are our formulas of what we're going to do. Okay, so we're going to plug our numbers in and we're going to add these things together because we're looking for the volume of the whole thing. So when I go to find my volume, I have 1/2 times 4/3 pi. What is my radius that it gives me in that picture in number 30?
4.
Okay, so times 4 cubed, and then I'll have plus, okay, because this is my hemisphere part. Now I got to do my cylinder part. Pi times the radius, which was 4, times, what's the height of the cylinder part?
8.
8. Okay. Now, does everybody know what those little marks mean on the number? What units of measure that is?
Inches.
Inches. Okay, so our units that we're measuring are in inches. So this is what we're going to work out. So if you haven't learned by now for this chapter, you definitely want access to some type of calculator or something because we have a lot of stuff that we have that has big numbers. Okay, so I'm going to do what I can here. 4 cubed, 4 times 4, 16 times 4, 64. Okay, so I know that part. 4 squared, I know is 16. So now I'm just trying to simplify everything. Okay, now I've got 1/2 times 4/3. I know 2 will go into 4 2 times, so I can cancel that part out. So I have 1 times 2 times 64 on the top, and then I still got a 3 on the bottom. Is 3 going to go into 64?
Yeah. No.
3 doesn't go evenly into 64. So we'll still have a fraction. So I have 2 times 64.
120.
Over 3 pi. That's this part. Okay. Now I still got to do this part. I got to take 16 times 8 over there. Whoops, I hit too many numbers. Which is also what?
$128.
Okay. So this is what I have. We need to try to add them together. We can add them because they both have pi on them. Okay. So we have 128 plus the fraction 128 over 3. So we end up with that. Y'all agree with me, yes or no? Now, if we wanted to, we could, sorry. If we wanted to, we could look at this and change it because we can plug in something for pi and get a decimal answer. But I've told you on most of the problems that we do, I prefer you just leave pi in the answer. Don't multiply by 3.14 unless I specifically tell you to. Okay, so this is all you have to do for number 30. We found the area of the hemisphere. We found the area of the cylinder. We added the two together, so we had the, not area, sorry, volume. So we had the volume of the entire solid figure. Now, 31 is similar, except instead of the hemisphere being with a cylinder, the hemisphere is with what shape?
A cone.
A cone. So we're still using the same formula for the hemisphere part, half of the volume of the entire sphere. But then for a cone, the formula for the volume of a cone is very similar to our volume for a cylinder, except since it narrows up into that one single point, we multiply it by a third. You remember it's 1/3 pi r squared h when you're talking about a cone. So those are our formulas that we're going to use for number 31. Okay, so you have to look at your picture, see that your radius is 3 centimeters and your height is 10 centimeters, and then we plug that in. So I will have my volume is equal to 1/2 times 4/3 times pi times the radius 3 cubed, because that was my radius from the picture, plus 1/3 times pi times 3 squared times my height, which was 10, correct? Yeah. Okay, so that's what we're working out for number 31. Okay. So now we just work on simplifying that. If you have calculator, you gotta start typing that in. Okay. So I know 3 cubed is 27. I know 3 can go into 27 9 times. I know 2 can go into 4 2 times. So I have 1 times 2 times 9. 18 pi for the hemisphere. I know 3 squared is 9. I know 3 goes into 9 3 times. So I have 1 times 3 times 10. So I have 30 pi for the cone. We add those together. So my volume for the whole thing
48.
48 pi centimeters cubed. Remember, if you're talking about volume is measured in cubic units, area is measured in square units. It's important that you put your units on your answers. Some of you on the quiz, you just put squared for everything, okay? Some of you didn't put any units on your answers, okay? So make sure that you're doing that. Okay, so that's number 30 and number 31. Now they are similar to what it wanted us to do on the chapter 9 review on number 20. Okay, I want to go do that one too. So we have another one of these kind where you have to add the two parts together. Okay, because most of them we did in class together were just one single figure at a time. So make sure you have those down, and then we're skipping to page 453, number 20. So get your book turned over to that page. Okay. Excuse me. All right, so page 453, it's one of the green review pages at the end. We have a picture that looks like this. Okay, you have a shape sitting on top of another shape. What shape is that called on the top? What shape is that one that's on the top called?
Triangle. A
That's
pyramid.
not-
A pyramid.
It's a pyramid, right?
Yep.
We have a pyramid. So we're gonna have to find the volume of the pyramid. Now again, just like I said when we were doing the cylinder, for your cylinders, your prisms, your pyramids and stuff, your main basic thing for your volume is the area of the base times the height. Now, for the cone and for the pyramid, where they narrow up to that single point, it has 1/3 in front of it. So for my formula for the volume of my pyramid is going to be 1/3. And then what shape is the base of that pyramid?
A rectangle.
It looks like a rectangle. So to find the area of the rectangle, you do length times width. So that's 6 times, is it a square? 6 times 6? Right? Looks like it's a square. And then the height of the pyramid. Now here's where you got to be careful. Look closely at your picture on number 20. The height that they gave you goes from the very top of the pyramid all the way down through the prism on the bottom. So that 7 is not the height of just the pyramid. That 7 is the height of the entire thing. So you're going to have to subtract. If you look over here on the side, you see the height of the prism that it's sitting on is 3 feet. So if I have the entire thing 7 feet, this piece is 3 feet, how far is just the pyramid? You just do 7 minus 3, which is?
5.
Really?
4.
4.
Okay. You do 1/3 times the area of the base times the height. Okay. So that is for our pyramid part. So I have 1/3 times 6 times 6, because that was the length and the width, times the height. So 6 times 6 is?
36.
6. 3 goes into 36, 12 times 4 is 48. So I got 48 for the part of the volume of the pyramid. Now I got to do the prism. The volume of the prism, it's a rectangular prism, okay? or a square prism, whatever you want to think, you've got the length times the width times the height. So I have 6 times what was the height of the prism over there on the side?
4.
The little number, no, the pyramid was the 4.
Oh,
So the little prism over here on the side is 3. So I have 6 times 6 times 3. So 36 times 3.
108.
So my volume for the whole thing, I add those together, the pyramid on the top, the prism on the bottom. And then it was measured in feet. So it's 156 feet. Is that right? Cubed, yeah. Because we were finding volume. Okay, so if it gives you a compound three-dimensional figure, compound means it's just got 2 put together. You find the volume of each part and then you add them together. Okay, but I wanted to do some of those because one like that will show up on your test when we have our test over chapter 9. So that's why I wanted to cover that. Okay, so everybody make sure that you have those problems down. And then I want you to make sure you have your chapter 9 notes. Did everybody fill in their chapter 9 notes that were in their folder?
Yes, I did.
Okay, we're gonna talk about the notes, making sure you got the right words in the blank for section 9.7 and talk about them just a little bit. And then we'll talk about common mistakes I keep seeing on the quiz. So then if you want to go back and maybe rework on your quiz, you can. Okay. So let me find my notes paper. I had it here a minute ago. All right. So for section 9.7, it starts there on page 441. It's talking about the geometry of spheres. And what they're doing here is they're taking a sphere, which our planet Earth is a sphere, and they're applying characteristics from a sphere to our globe to give us measurements to tell us locations. Okay. Now, the equator is the great circle. Remember, I talked about a great circle yesterday. It goes all the way around the sphere, defined by the plane that passes through the center of the Earth and is perpendicular to the diameter from the North Pole to the South Pole. So North Pole, of course, is, you think of north is up, South Pole's down. So you have a diameter that connects those 2 points together. And then the equator is perpendicular to that, which means they make what kind of degrees? Perpendicular means what kind of degrees?
9.
9 degrees.
Yep, 90.
The equator divides the Earth into the northern and southern hemispheres. There's that word again. It's half the sphere. The top half is the northern hemisphere. Okay, so that includes like North America, England, Russia, okay, North Pole, all that stuff that's on the top half. And then the southern hemisphere has like your South America, Australia, Antarctica, all the things that are on the bottom half. Okay. The second great circle contains the prime meridian, which is a semicircle from the North Pole to the South Pole, passing through Greenwich, England, and divides the Earth into the eastern and western hemispheres. So your first answer blank was equator, and then the second one was the prime meridian. The other half of this vertical great circle is the basis for the international dateline. Okay, latitudinal, that's a big word. If you can't spell, it's there on page 441. Latitudinal lines are parallel to the equator. So the equator is going around this way. It goes around this way. So parallel to it means they're also going around this way. So those are our latitude lines, and they tell how far north of the equator or how far south from the equator a place is. Okay, longitudinal lines are great circles that go up and down through the north and south poles going around. And so they will tell how far east of the prime meridian or west of the prime meridian a location is. Okay. In this geographical coordinate system, the location of each point on the sphere is described by its latitude, the number of degrees from 0 to 90 north to south of the equator, followed by the longitude, the number of degrees from 0 to 180 east or west of the prime meridian. So latitude always comes first. So it tells you how far north or south it is first, and then it tells you how far east or west. Okay, so those, make sure you had all those words filled in your notes. Okay. Now, from what I just read on your notes, on page 444, we should be able to answer 1 through 4. Page 444. So it's section 9-7. We should be able to answer 1, 2, 3, and 4. From what I just read from page 441, to make sure we filled in our notes. It says determine whether each statement is always, sometimes, or never true. So it said longitudinal lines are great circles. Longitudinal lines are great circles. Always, sometimes, or never.
Hold on, let me find it. Total lines. Always?
Always, because by definition, I said they were longitudinal, okay? Longitudinal lines are great circles which pass through the north and south poles. So in the definition, it tells you that they are great circles, okay? Number 2, latitudinal lines are great circles. Think about the latitudinal lines, okay? When you're talking about the ones going north and south, are they always going to be all the way around the sphere?
Yeah.
If you think about the equator, it's a great circle going all the way around. But what happens as you go farther north or farther south? They'll be all the way around, or are they going to get smaller?
Small.
They're going to get smaller. There's still circles around the sphere, but they are not a great circle around the widest point of the sphere. Okay, because they're going to end up getting smaller as they go farther north. So that one's going to be sometimes, because your equator is, but the rest of them are not. Okay. Number 3. Lines of latitude intersect each other. Lines of latitude intersect each other. Always, sometimes, or never.
Lines of latitude.
Let's look at our definition for latitudinal lines.
Sometimes.
Huh?
Sometimes.
Nope. Never. Okay? Because if you look at your definition for latitudinal lines, it says latitudinal lines are parallel to the equator. So if you're talking about lines that are parallel to each other, do they ever touch each other?
No.
So that one's going to be a never. Okay? And then on number 4, it says lines of longitude intersect each other. Now the longitudinal lines, remember it said they all pass through the north and south poles. So if they all pass through the North Pole and South Pole, are they all going to meet at the North Pole and South Pole?
Yeah.
Yeah.
Always.
Okay. Now, let's skip down to number 17 on that same page. Okay. And it says, if you are walking south along a longitudinal line from the North Pole. So let's think about our directions, okay? Here's This is going north, this is going south, this is east, this is west. Okay? If you are walking from the North Pole south, so I'm walking down this way, and then it says you turn east at the equator. What is the degree measure of the angle of your turn?
90.
90 degrees, because if you're going straight down a longitudinal line and then turn east at the equator, these are going to be perpendicular to each other. So it's 90 degrees. Okay? All right. Now, on 15 through 16, on 5 through 16, it's talking about actual measurements, like looking at a map. Okay? So, you had some examples there in your book of looking at that, looking at a map, trying to find different states or whatever. Okay, using the latitude and longitude. Okay. If you have access to a map or globe at home that has the latitude and longitude lines, okay? If you have access to a map or an atlas that has the latitude and longitude lines, and you can see the lines going across, I've got my equator on here, and then it counts the degrees going each way, and then my prime meridian runs through Greenwich, England, so it's running like right through the middle of the book where the pages meet, and then it counts 0 and up going west, and 0 and up going east from that point. So if you do have access and want to try some of those and send in answers to that for me, then I will count them as extra credit. Okay, but you do not have to. Everybody understand that? Everybody understand that? If you have access to a map where you can actually try to do the latitude and longitude and answer 5 through 16, I will give you extra credit points for those, but you do not have to. Okay, my main thing is making sure you knew how they related to our spheres. Okay, does anybody have any questions on any of the blanks on their notes? Everybody's got their notes filled in? Okay, because what I would like is any of the work that you have from chapter 9 that you have not already sent me, including your notes, okay, filled in. I would like for those to be sent to me so I can give you more points for your daily work other than just our Zoom meetings, because that kind of helps your grade too. So basically, if you followed along and did the problems on the worksheets and stuff that we did in class, and you filled in your notes, then that gives you more points, possibilities, okay? Now, on the quiz, I went over again yesterday some stuff on there. Some of you still aren't using the right formulas. I don't know what else to do when I basically told you which formulas to use yesterday. On there, you got to know what the shapes are, okay? You got to be able to look at it and say, okay, that one's a prism, that one's a cylinder, that one's a cone. You have to be able to figure that part out. But there are a lot of you. I will go back through and individually send you messages through My Schoolworks about problems from the quiz that you need to look back on. A lot of you threw away points on number 2 because you didn't answer the very first part of it. On number 2, the very first answer blank said, name the type of solid figure by its net. You had to tell what 3-dimensional shape it was. We talked about it in class yesterday, that it was a type of a prism, but then most of you still didn't put any answer whatsoever. You had a big long answer blank out in front of problem number 2, and that was where you were supposed to put what shape it was. Whether it was a circular cone, a rectangular prism, a square pyramid, whatever it was, you were supposed to put those words in there. And most of you didn't do that, so that was like 5 points that you just threw away. Okay, and we talked about that one. So please, please, please look, check your messages in My School Works this afternoon. I will try to have them all in there by like 3 o'clock, okay? So that it tells you which ones you need to look back on. So that's something you can work on getting over the weekend, okay? Everybody got that? All right. Have a good weekend. Make sure that you check. Kaya, just keep trying to get stuff sent in. If you can't get it sent in, then I know like daycare's opening back up. So, I mean, if you have to just send stuff with your mom or whatever, and I can check it off and then send it back home, we'll do something. Okay? So we'll figure something out. Watch for your email about your quiz. Make sure you correct your quizzes. And I'll see you on Tuesday.
Okay, bye. Merry Christmas.
He's so weird. Oh, mercy.